How are you?
Good. Sorry about last week.
That's fine.
Yeah, I recently switched from CenturyLink to Comcast because their system is better, but I'm finding out that there are some more technical problems with Comcast. And last Tuesday was one of them. It was down for like 4 hours.
Yeah, that's what happened to me
Yeah.
when we tried to switch, but we switched back.
Oh, really? You tried switching to Comcast and then you switched back?
No, we switched to CenturyLink and then switched back.
Oh, really? So, okay. All right. We left off with the problem before this last time. Is that what you want to do tonight, is geometry?
Yeah.
Okay. You don't have any problems in your algebra class? You have a final coming up within a couple of weeks, don't you?
No, I don't have finals.
You don't have finals? Okay.
Middle school, yeah.
So you don't have any kind of major test in algebra that you have to prepare for?
Not in algebra, no.
Okay. Well, then let's continue on in geometry. All right. Last time we talked about shaded region problems are always what kind of problems?
No. Sorry. I don't remember.
They're always subtraction problems.
Oh, okay. All right.
Okay. So here they give us the side of the square is 2x plus 1. And they give us the sides of these smaller squares, 3 and 6. And they give us the area of the shaded region.
All right.
Well, let's see if we can come up with an equation that represents the area of the shaded region, and then we can probably solve for x. So, what's the area of the big square?
6 times...
No, the area of the big square.
Oh, sorry. 2x plus 1 squared.
All right. So we've got the area of the big square, which is 2x plus 1 squared, minus the area of the smaller square and minus the area of the medium square. What's the area of the smaller square?
Would it be 3 squared?
9. What's the area of the medium square?
36.
Okay. So this whole thing is the area of the shaded region.
Okay.
Okay, because the area of the shaded region is the area of the big square minus the areas of the two smaller squares. Well, there's the area of the big square, and there's the area of the two smaller squares. And
all right.
They've given us the area of the shaded region is 76. So now I can write an equation, 2x plus 1 quantity squared minus 45 equals 76. So, as with most geometry problems, it always comes down to an algebraic equation you have to solve.
All right.
So let's solve this. What's the first?
So, you would add 45 to both sides.
Okay. Now, there's a couple of second steps here.
And then you find the square root of both sides of the equation.
Okay.
And that'd be 2x plus 1 equals plus or minus 11.
Very good. You remembered the plus or minus 11. I mean, you remembered the plus or minus part. Next step?
Yeah. Then you would subtract 1 from both sides, so then you'd get 2x equals 10, negative 10, or 12.
Well, okay. Let me suggest a different way of writing it. for the moment. Now what's the last step?
You divide both sides by 2.
That whole thing. So
Yeah.
x is equal to that whole thing. And now what are the two different values that x could be?
X could equal -5 or 6.
Positive 11 minus 1 would be 10 over 2, so positive 5. Minus 11 minus 1 is minus 12 over 2, or -6. Well, we can tell that we can throw out the negative solution, because if you stick in -6 for x, you get a negative number for the dimensions on this square. And in geometry, you cannot have negative dimensions. So we throw that answer out, and the only answer we have left is x equal +5.
All right.
Advanced. All right. This will be a true test. I'm not even sure it makes sense for us to do the advanced, but why not? Let's take a look at them.
So,
Let me try to draw a picture of this so we can label everything. All right. If square ABCD has area 49, what's one of its dimensions?
7.
Okay. If DEFG has area 9, what's one of its dimensions?
3.
What's this side right here, from here to here?
4.
What's this side right here, from there to there?
So you would have 9 plus 16, 36, 6.
9 plus 16.
Oh, sorry, 5. My bad.
It's all right. And notice that that is a 3, 4, 5 triangle, which is what you're usually going to be looking at. Is they love 3, 4, 5 triangles. So when you see a right triangle that has a 3 and a 4 in it, you don't generally have to go through the Pythagorean theorem. You can just know that the hypotenuse is 5. Okay, so what's the area of this square right here?
So that is 25.
Right. Okay, so this problem was advanced only because it had 4 steps. There was step 1, figuring out that that side is 7. There was step 2, figuring out that side is 3. Step 3 was subtracting 7 minus 3 to get 4. Step 4 was figuring out the hypotenuse, which is that side. And step 5 was figuring out the area. So there were actually 5 steps to this. None of them were hard. They were all simple. But that is very typical of a geometry problem. It's just usually got lots of steps. Any decent geometry problem, you're always gonna have to do multiple steps.
All right.
Okay, so ABCD is a rectangle. And the area of AEB is 8.
Okay. So ACD. So that's an isosceles, right? Where two sides are the same?
It is.
Yeah.
More importantly, what is this point right here?
That point is...
Is it halfway? Is it half the width or?
Okay, so then it would have an area of 16, right?
Well, no, the area is 8. They want the area of ACD. Well, now, we know that the area of ACD is half of the area of the rectangle. But they don't give us the area of the rectangle. They give us the area of AEB only.
Alright, so then...
The key to the understanding of this problem is what is the area of AEB relative to the area of the entire rectangle?
Okay. So...
This is a little tricky.
Yeah.
If this side was, say, 6, where does this point occur?
Halfway between.
Yeah, that's the key.
Oh, okay.
And since the area of the entire rectangle is the base times the height, then the area of that part of it is a triangle that has a base of B and it has a height of 1/2 h. In other words, this distance right here is 1/2 h. So the area of this part of the triangle must be 1/4 the area of the entire rectangle, because it would be, it's 1/2 base times height. Well, base is the same, it's B, but height is 1/2 height. So 1/2 times 1/2 height, or 1/4 base times height. So this area right here is 1/4 of the rectangle area.
All right.
If that's 1/4, what is this one down here?
8. Or 1/4.
1/4 also. You can see by symmetry that they're going to be the same. Well, that makes this half and this half. So they're saying the area of this thing is 8. So what's the area of the entire rectangle?
It would be 8 times 4, which is 32. Yeah, 32.
But they're asking for the area of ACD. What part of the rectangle is ACD?
That's 2 rectangles that make up half the triangle, so it'd be 16.
Okay, cool. Yeah, it's also half of the rectangle. One thing about geometry that's worth knowing is if you have a rectangle and you put a triangle inside of that rectangle, no matter where you put it, I can put it like that, I can put it like this, or I can put it like this. Notice the area of the triangle is always half of the area of the rectangle. So we know that ACD has to be half the total area of the rectangle. All triangles that you put in there are always half. Thus, we get the formula for the area of a triangle is 1/2 base times.
All right.
Well, all right. What's the perimeter of this rectangle that I've drawn as a function of h and b?
2b plus, 2b plus 2h.
Okay. Now, the rectangle that they've given us has a perimeter of 6w.
Yeah.
If one side, and they left out a h, if one side has length w over 2, what's the area of the rectangle? Well, if I make that w over 2 is one side of our rectangle, and they didn't say which side, so I'm just going to pick one.
So then it would just be 6w.
What's the other side? We need the other side.
That'd be.
In other words, I've assumed that w over 2 is h. Okay, so now we got 2 times the base plus 2 times w over 2 equals 6w. You with me?
Yeah. So that
All
means
that for the base.
2b equals 5w.
So b equals 5w over 2. So now I can label this side. That's 5w divided by 2, right?
Yeah.
Now what's the area of that rectangle?
5w squared over 2. Over 4, sorry.
Okay, hold on. We got 5w over 2 times w over 2, 5w squared over 4. Good. You can see these aren't too hard. Just lots of steps. All right, let's take a square. And it said the length of each side of square A is increased by 100%. So if side A was 3, what is side square B going to be?
One second, let me read over the equation again really quick. Well, if it's increased 100%, then it becomes, would it become 2 times bigger
Yeah.
or just be the same?
No, 2 times bigger,
Right.
for sure.
Sorry.
In fact, we don't need to put a number there. Let's call that x. So this is going to be 2x.
Yeah.
If the length of the side of square B is increased by 50% to make square C, what's the side of square C?
Square C would be 3x.
Okay. By what percent is the area of square C greater than the sum of the areas of square A and B?
Okay, so
Well, what's the area of square A?
x squared.
What's the area of square B?
4x squared.
Add those together so that A plus B equals what?
5x squared.
What's the area of C?
C is 9x squared.
So how does 9x squared compare to 5x squared? How much bigger is it?
Would it be?
Remember, 100% is double.
Yeah.
This
So
isn't quite double. It's 9.
a little bit less than 100%, so 80%.
Yes. And the way you actually can get that is the x squareds cancel out. So the ratio is 9/5. Okay, well, 9/5 is 1.8, which makes it 80% larger because of the 0.8.
All right.
A rectangle with integer sides, meaning no fractions, no decimals, has a perimeter equal to 10. Hold on a moment. So if I had a piece of paper that was 60 by 24, and I wanted to make a bunch of these rectangles by cutting it out of this, how many can I make?
All right.
A little bit of a trial and error problem. What's going to give us a perimeter of 10? Let's experiment with a few. What are some possible answers?
Like a 2 times 3 triangle.
Okay, that works. What else works?
Well, technically 2.5
It's
squared.
got to be an integer.
Oh yeah.
Okay, so
1
really
and 4
only
work.
2 answers. 1 and 4 or 2 and 3? All right. If it's 2 and 3, how many rectangles can I make out of this thing that are 2 and 3? This is a pretty difficult problem, but it's good for you to look at this problem.
All right.
Let's just go through both situations, the 2 and the 2, 3 and the 1, 4. Let's say that the rectangle is 2 times 3. Am I going to be able to cut this thing up without anything left over?
I don't think so.
Well, if I put a 2 by 3 right there, that's going to be the 2, that's going to be the 3.
Well, there should be like 12 rectangles down and 20 across.
So it fits perfect.
Yeah.
Okay, so 12 down, 20 across, that would give us 240 rectangles. That's one possible answer.
You could also make it.
Okay, now let's see how it works with 1 and 5. Does it matter? Let's see. If we 5, the important part here is to figure out if both of them divide into these numbers. 5 does divide into 60 perfectly. 4, I'm sorry. 1 and
Yeah.
my bad. How many of those rectangles do we get?
24 and 15.
That's more.
Yeah.
That is 360 rectangles. And the question is, what is the greatest number of these rectangles? 360.
Yeah.
Okay. New section, circles. Only thing you have to know about circles is the area and the circumference. What's the area? The general formula?
Pi r squared.
And the circumference?
Isn't it? I'm not sure.
Same three numbers in slightly different order.
Pi squared r? 2 pi r.
Okay?
Right.
Now, the reason those are the only two formulas you need to know is there's really only three things about circles. There's area, there's circumference, and there's the radius. Well, given the area, you can always figure radius. Given the circumference, you can always figure radius. Given the radius, you can figure either one of these. So of the three pieces of information, you only need one of them to be able to figure out the other two. That's important. If the area of a circle is 64 pi, then the circumference is what?
Then the circumference.
Let's take our area formula. They've given us the area is 64 pi.
Oh,
We know that that's equal to pi r squared. Does that allow us to figure out r?
Yeah, you would get 16 pi.
Correct. In other words, once they give you the area, we can figure out the radius. Once we have the radius, we can figure out the circumference. This one's pretty easy. The area of A is, the radius of A is 2, the radius of B is 3, the radius of C is 4. What's the perimeter of that triangle? What's length AB equal to?
Length, sorry. Is 5.
What's AC equal to?
Six.
And what's BC equal to?
7.
What's the perimeter of that triangle?
12 and 6. 18.
Right. All right. It's a good place to stop.
All right.
And we'll make a note and we'll pick up from there next time.
Okay.
All right, David, have a good week. I'll talk to you next Tuesday.
Okay. Thank you.
You're welcome. Bye-bye.